Hey guys, Mr. Riz here again to help you out with the 1.2 notes, or not 1.2, this is 1.3. I was just looking at there and there. So this is going to be day 2 of it. So what we're going to do now is look at the rational function properties here. So here's the fancy definition here, is if P is a polynomial function and C is a real number, then the limit as x goes to C of P of x equals P of C. So if we can plug it in, it will work. Now, if R is a rational function, given that R of x equals P of x divided by C, basically meaning we have a function that is two separate functions being divided by each other. And C is a real number such that Q of C does not equal 0, then we plug it in. So basically, this is saying if we have a fraction here, if we ever can just plug it in, we're going to plug it in. So let's annotate this here. Like if I can take 1 and plug it into this equation here and get 1 squared plus 1 plus 2 over 1 plus 1. Let's see, that's what 1 squared is 1 plus 1 is 2, 2 plus 2 is 4 over 1 plus 1, 2. We get 2. The problem we'd have to watch out for, and we'll talk about today, is what if we were going towards -1? That would be no good. We don't know how to do that yet. So with these direct substitution properties, these basic properties here, if we can plug it in, we're just going to plug it in. So if we got this limit here as x goes to 0 of this function, even though it's a square root function or a cube root function, if we can plug it in, we plug it in. 0 squared plus 4 would be the square root of 4, which is just 2. Same thing here. Okay, if we can plug 3 in, the cube root of 2 times 3 squared minus 10. Well, let's see, that would be 3 squared is 9 times 2 is 18 minus 10. So that's a cube root of 8, which is just 2. So if we can plug it in, we plug it in. And it doesn't matter for trig functions, we do the same thing. So this is just more practice of what we did last time. So if we have two separate functions and we're going to go ahead and plug them into each other, we can do that as well. Just to finish off these notes here. So if we're going towards some number of 5 times g of x, well, I know g of x is 2. So 5 times 2, 10. All right, now what if I have a limit of f of x plus g of x? Well, I know that limit of f of x is 3. For g of x, that's 2. I can add them together. That's 5. Same thing if we multiply. F of x is 3. G of x is 2. We can multiply our two answers here and get another separate answer of 6. And it works the same way with division. 3 divided by 2, and we can leave it like that. Okay, so that's what we did last time, and that's the best thing you can do, is if you can plug it in, you plug it in. What we're going to work on today is what if we can't plug it in? So say we have this limit here that's x cubed minus x1 over x minus 1, where it works, the graph looks out like this, except for we know we would have a hole at 1, because I cannot plug 1 into the bottom here. What we're going to do is see if we can find an equivalent function that matches every single point on the graph except for that one value. Well, if I can go ahead and plug direct substitution in every single point here, if I use direct substitution for this equation and get this answer point here, it will tell me where the hole is on my original problem. So what we're going to do is to use a rational solution, meaning we're going to divide out to find an equivalent equation and use direct substitution there. So what does that look like on some problems here? All right, and this is what it's going to look like. So we'll do a bunch of examples here. You should be set. So, okay, can I plug 0 into this equation? No, I can't, because I'd get 0 on the denominator. So I need to divide out to find an equivalent equation. So can I divide something or factor out something from the top here? I sure can. I could factor out an x. So I would get x plus 3 over x, meaning these x's cancel out. And so really what we're doing, an equivalent equation would be an x plus 3. Now, can I use direct substitution there? We sure can. There's no denominator. I don't have to worry about anything. And so let's see, this would be 0 plus 3, which means the limit would be 3. So if we were going to graph this equation here, there'd be a hole on the graph, but that hole would be over 0 up 3. All right, next problem here. All right, what about -1? Can I plug it in? No, because the bottom would be 0. So can we factor the top at all? The top is the difference of squares. That is an x plus 1 times an x minus 1 over x plus 1. We look there. Now our x plus 1's cancel out. So really we're finding the limit as x goes towards -1 of x minus 1. And that is a problem I can use direct substitution. So this would be -1 minus 1, which would equal -2. Okay, more practice here. Alrighty, can we plug 2 in for this one? No, we can't. Okay, so the theory is, I mean, this is the difference of cubes. I'm not sure how many of you guys remember this at all. I sure don't. But the theory is I could factor out this x minus 2, right? That would be the best thing I could do. If I can't, well, then it just doesn't exist. But for right now, we're going to do all the ones that work out nice. So let's use synthetic division. All right, so that means my factor is 2. I have a 1x cubed, 0x squared, 0x, and a -8. See if we remember how to do this. Drop the 1 down. 1 times 2 is 2. Add them together is 2. 2 times 2 is 4. Add them together is 4. 4 times 2 is 8. Add them together is 0 because that's happy. That does work out. So we would have 1x squared plus a 2x plus a 4 at the end. So that's one way we can go through and figure out what it is after it factors out. So that means we can cancel out our x minus 2. So really this is an equation of limit as x goes to 2 of x squared plus 2x plus 4. And let's see, that would be 2 squared plus 2 times 2 plus 4. So we got 4 plus 4 plus 4. That'd be 12. Okay. So we're not always just factoring out of the bottom here. Sometimes we can look and see, okay, if I plug 0 into the bottom, it doesn't work out. But sometimes here, okay, I get x over, I could factor out an x times x minus 1. And when this cancels out, I get an equivalent equation of 1 over x minus 1. And that's something I can now use direct substitution in. So what's 1 over 0 minus 1? That'd be 1 over -1, which is just -1. All right. So let's keep doing. I think we got a couple more problems here to check out. Remember to pause the video and go back if you guys get confused by anything. We've got 2 more to go here. All right. What about x minus 4 over, okay, I can't plug 4 in because that would be 16 minus 16, but we could factor out the bottom. The bottom would be an x plus 4 over x minus 4. So cancels out the minus 4's, and this becomes really the limit as x goes towards 4 of 1 over x plus 4. So what's 1 over, direct substitution now, 4 plus 4, and the answer would be 1 over 8. All right, and one last problem here. All right, cannot plug -3 in because we would get 9 minus 9. So let's see, the bottom does factor to an x plus 3, x minus 3. What does the top factor? Okay, what 2 numbers multiply to give us -6, add together to get 1? That'd be an x plus 3 and an x minus 2. All right, so cancels out the plus 3. So really this is the limit as we go towards -3 of x minus 2 over x minus 3. Which would be -3 minus 2 over -3 minus 3. So that would be, let's see, -5 over -6. So we'd just say that's a positive 5, 6. All right, so let's take a quick brief look at the CYU to see if you guys would have any trouble with this. Part 2 here. All right, so we'll go to our CYU. Let's open it up. Make sure I'm still screen sharing this. All right, 1.3 CYU2. All right, so direct substitution, factor out the x squared, should be easy there. Factor out the x plus 2. Do we need help with that factoring? We might. Here, I'll give you a clue here. All right, it's going to be what 2 numbers multiply together give us -6, add together to get 5. That'd be a negative, or a 6 and a -1. 6 and a -1, so it'd be an x plus 6 and an x minus 1, but we could divide them both by 3 because that's the number in front. And so the top should factor out to an x plus 2 over a 3x minus 1. And then we still have x. So hopefully you guys can see what to cancel out and then what to plug in. All right, the bottom one here, number 3, okay, that's another one. Let's see, does it factor out? We'll probably use synthetic division here. So we put -1 in our root here. We have 1 x cubed, 0x squared, 0 x's, and a 1. All right, 1. 1 times -1 is -1. Add them together is -1. -1 times -1 is a +1. Add them together is a +1. +1 times -1 is a -1, and that's 0. That's happy. It's a root. So the top would come out to be an x plus 1 times a 1x squared minus x plus 1. All right, so cancel things out, plug it in. All right, should be able to factor out an x from the top and bottom here. Should be able to factor that to a x plus 5, x minus 5. What you might need to do to the top is factor out a -1 to make that an x minus 5 on the top. Just giving you guys a couple clues if you're watching this videos and you need some help. And then the top one here, let's see, that would factor out on the top. Yep, you guys should be able to factor. Those are simple factors. All right, guys, if you need any help, just let me know. But hopefully you guys are getting the hang of this. You're seeing how the difficulty rises a little bit, and that's what's going to happen each time. All right, guys, have a great day. I'll see you guys next time.